Hi, this is Dr. Eddie Morgan over at Clovis East High School, ready to help you with your homework again. Tonight we're looking at Math 1 Worksheet 6.1. Remember, each of these questions mirrors or sometimes is exactly the problem on your homework. So in this case, if you can find the one you're looking for, fast forward to it, and we should be able to help you out. So let's get started. All right, in our first problem, it says to make a frequency table, a histogram, and then a cumulative frequency table for the following data. There's a couple ways to do it. One of the things that I do, takes a little extra time, but it'll be helpful later on, is just to write them in numerical order. So for example, I might start here and say, okay, 15. So I'm going to write 15. I'm going to say 9. You just got to kind of make room for it. Doesn't always work out. 10. 14. Another 10. An 11. Another 10. An 18. A 21. Another 10, well, let me change that to a 10 and make that an 11. Another 14, squeeze that in there, and then a 22. Okay. So now I want to know how many are between 9 and 12. Well, 9 to 12 would be this range here, so I can count them. 1, 2, 3, 4, 5, 6. So that means there's 6 in this range. 13 to 16 would be here. 1, 2, 3. So there's 3 in that range. 17 to 20, there's only 1. And then the last two, 21 to 24, there's 2. So that's my frequency table. It's just telling me how many is each in category. To make a histogram, I'm going to use the frequency, and I'm just going to make a picture of it with boxes. So between 9 and 12, there are 6. So come over here to go to 6 and make yourself a box. That's the first box. The next one is a 3. 13 to 16 is 3. So again, see, there's 3. Then finally in 17 to 18, I only have 1. And then it pops up on this one to 2. And that's what our histogram looks like. Now to make a cumulative frequency, we're just simply asking how many. It's kind of like asking what's the frequency of all that number and below. So notice my frequency table is the same as before. And if I ask all the ones between 9 and 11 and below, it's just 6. But now when I move to the next one, it's 3 plus the 6. My cumulative up to this point then is 9. Now add 9 and 1 and we get 10. And finally 10 and 2 is 12. And of course this should be the number of data points that you actually have. So there's our first problem. Our second problem is like the first one. I'm going to start again by making a list of all these in the order that they're in. And so we're going to start with number 10. So 10 here, I'll just put 10 down here. And then I'm going to have number 14, I'll stick that out here. Number 6 is going to be down here someplace, looks like my lowest one. And then I have a 15. I have a 21, that could be higher up here. I have an 11. And then I have a 12, another 10, another 11, an 8, 2 8s. Put another 8, a 13, slide it in there, another 10, and then an 18. By the way, to make sure you got them all, you might want to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I know that I got them all. I didn't miss a number. So first setting here is 6 through 9. So that's going to be these 3 here, 6 through 9. So there's 3 in that category. 10 through 13 is here. There's 1, 2, 3, 4, 5, 6. There's 7 in babies that weigh in the range of 10 to 13 pounds. 14 to 17, there's 2 of those. And 18 through 21, there's 2. So there's my frequency table. So now to make the histogram, in my first category 6 through 9, I have 3. So I come over here to 3 and make my box, and that's my first box. From 10 to 13, we have 7. Okay, so 7 is all the way to the top. So I'll make my box indicating that in this category, there are 7. 14 to 17 goes only 2. So 2 is right here, come across there. That's there. And the next category is also 2. So there's my histogram. It's just a visual picture of what our frequency table is saying. Now to do the cumulative table, let's write in the frequency that we already found the first time, 3, 7, 2, and 8. And in each case, the frequency is the number in that category plus all the ones before it. So it starts being 3, but the next one here becomes 7 plus 3, or 10. The next one is 2 plus 7 plus 3, or 2 plus 10 is 12. And then the next one, 2 plus all the others, is 14. So it cumulative is adding them up as we're going. Problem 3 asks us to tell whether each of these histograms is uniform, symmetric, or skewed. If you remember our definitions, to be uniform means that they're all about the same. So if I had boxes like this, all pretty much the same. To be symmetric means that they kind of have a center point and each side has about the same amount. In other words, if I have a big center like this and then each side is about the same around that, that's called symmetric. To be skewed means that I might have a high point here, but I tend to have 1 point more on the other side. There's more on the left here, so this is skewed to the left. So let's take a look at this. The first one, you'll notice that if I look at the center, even though it's going down, on each side, left and right of that line, it's about the same. So that would be typical of a symmetric one. On number 4, the center here is here. I could even draw the high point, though, is here. And notice on the high point, everything is to the right. So we would call this skewed to the right. Change that. This is actually skewed to the right. High point is not the center. If we move on to the next one, you'll notice that there's the center. Key thing to notice here, though, is all of them are about the same height. And this one we would define as uniform. All the values about the same. And then again, number 6, here's the center, but the high point is right here. And notice that most of that is to the left. So we would call this skewed to the left. Again, made an error there, but skewed to the left. The high point is not the center. So histograms, we're just describing the shape. Problem 7 gives us a histogram, and now we have to interpret it and see if we can ask a few questions. The first question says, fewer than half of the swimmers are younger than 12. Well, first thing we have to do is figure out how much is half. So notice here, I have 7 plus 6 plus 8 plus 7 again plus 5. And that adds up to 7 and 6 is 13, 21, 28. So this adds up to 33, which implies 33 and a half divided by 2 is about 16.5. So the question is are fewer than half the swimmers younger than 12? Well, younger than 12 means from here. So younger than 12 is going to be 7 plus 6 plus 8. So that's going to be 7 and 6 is 13 plus 8 equals 21. And the question was fewer than or less than, but that is not less than 16.5. So we would have to say this statement is false. There are more than half the swimmers are less than 12, not less than. All right. Next one says only 5 swimmers are older than 13. Well, to be older than 13 means you're in this category. And here, only 5 swimmers are older than, and sure enough, that's 5. So that's true. There are just 5 swimmers that are older than 13. C says there's an equal number of swimmers that are less than 10 and older than 12. Well, less than 10 means I got this category here. So less than 10 is going to be 7 plus 6, which is going to be 13. And greater than 11 is going to be the rest of these, here, 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 and here. So that's going to be 8 plus 7 plus 5, which is 20. So are those equal? No. So this is false. Then finally, the number of swimmers who are 14 and older is equal to the number of swimmers younger than 10. Okay? So the number of swimmers who are 14 and older is this category here again. So greater than 14 is 5. And the number of swimmers that are younger than 10 is this group again. And so that's going to be less than 10 is going to be 7 plus 6, which equals 13. And 5 does not equal 13. So this statement is false as well. So in this data, you have to just find out what you're looking for and compare the numbers and see if it's true or false. Problem 8 and 9 asks us some questions. First question is a vocabulary question. How might a frequency table help a store owner determine the busiest business hours? Well, let me just give you a little hint. One of the hints is, well, when are the hours the busiest? Well, if I draw a frequency table and suppose I set out, from 8 to 10 and from 10 to 12 and from 12 to 2 and 2 to 4 and put down how many customers I have, you see, that could help me. A store owner could look at a frequency table, column, and pick out what are the busiest hours so he can make sure then that he has enough workers in the store during those hours. So frequency can tell me, when do I have the most customers? When do I make the most sales? Or when's the least amount of time so that I don't have too many workers? Number 9 says to compare and contrast. What's the difference between symmetric histogram and a skewed histogram? Well, generally speaking, you might look at what's the high point or sometimes the low. And in this case, usually it's the high point. And if I'm looking at it and I see that the high point, I look at that higher or low point and I say, if I drew a line there, do the two sides equal each other? Are they about the same? In other words, a symmetric histogram has roughly the same shape on the left and on the right if you folded it in the middle, but a skewed one tends to be slanted and have more on one side than on the other. Problem 10 asks us, how can we use a frequency table of a data set to construct a cumulative frequency table? Well, first thing, ask yourself, what does the word cumulative mean? And it means the total values up to that point. The frequency tells you how many is at that level, but the cumulative tells you how many is at level plus every level before it. In other words, you're going to add the frequency of each interval to the frequencies of all the previous. So for example, if I had frequencies that were going 3, 2, 1, 4, my cumulative would be at this point 3 is 3. The next one is 2 plus 3. That level and all the other ones behind it. Then the next one is going to be 3 plus 2, 5 plus the 1 is 6. And then finally add the next one and you end up with 10. So the cumulative takes how many's in that level plus all the ones before it. Problem 11 is an error analysis. You notice the student made the frequency table at the right using the data below. What's the error? Well, a hint on this one is to ask yourself, what's missing from the table? And if you look closely, what's missing is there's a 20 and a 29 and a 40 and a 49, but there is no 30 to 39. Now that's understandable because there's no 30 to 39 in the data. However, when we build a frequency table, we have to include all the intervals. So we simply have to write this again and set up our table so that we have a 30 to 39, even though there'll be 0 in that category. So that's the error and that's the correction. All right, that does it for this assignment. Hope you do well in class.